Today's lesson is about z-scores. A z-score informs you of how many standard deviations away from the mean a value is. If the z-score is positive, that means the value is larger than the mean. If the z-score is negative, that means the value is less than the mean. These two equations show how to calculate z-scores using the mean and standard deviation as well as the value given. These two equations are fundamentally the same thing except for they have different notation. The one on the left showcases the population standard deviation and mean. Mu is your mean and sigma is your standard deviation for a population. On the right side, this is the sample mean and sample standard deviation given with x bar and s. So depending on whether you're working with a population or a sample value and data set will determine which one you use. Fundamentally, it doesn't matter which one you use. You could actually make a mistake and still get the same z-score. But just know that this notation just designates population versus sample. So we can calculate z-scores anytime we have a standard deviation and a mean given for a data set. And if they ask for a z-score value, you're going to use one of the above formulas. Now, the formulas are really useful because if we are given a data value that is on a whole number multiple standard deviations away from the mean, it's a little bit harder to calculate without a formula. In this example here, it says a certain brand of light bulbs has a mean life of 100 hours and a standard deviation of 9 hours. It'd be really easy to calculate the z-score for a data value like 109. Because 109 is 9 values away, and our standard deviation is 9. So our z-score for 109 would be positive 1. Likewise, if we had a score of 91, that's negative 9 away, which is just a standard deviation below, so my z-score would be negative 1. However, these three examples here, A, B, and C, are not whole number multiples away from the mean.